Amid the harsh deserts of the Middle East, where there is nothing but rock, wind, and burning sun, the people of Israel achieved something extraordinary. They carved more than 12,000 kilometers of canals through barren land. A massive artificial river system designed to channel billions of liters of seawater deep into the desert. But Israel went even further. They turned that seawater into fresh, drinkable water, using some of the most advanced desalination technology on Earth. How does a nation force rivers to flow through sand? And how do they turn the sea into life? Let's explore one of the most remarkable engineering achievements of our time: the Negev Desert. For decades, the Negev Desert was a land almost impossible to survive. Dry, cracked, silent. Temperatures climbed above 110 degrees Fahrenheit. Rain fell only a few weeks each year. Aquifers shrank. And agriculture struggled to stay alive. Many families survived on water brought in by trucks, a fragile existence in an unforgiving landscape. Yet only a few dozen miles away lay the Mediterranean Sea, vast, blue, and unreachable. That contrast inspired Israel's boldest idea: bring the sea into the desert. The Desert Water Project. In the year 2000, Israel approved the Desert Water Project, a $3 billion mission to challenge the desert itself. The first task was to transform the Negev into a workable construction zone. Engineers mapped dunes with satellites and ground-penetrating radar. Survey teams drilled hundreds of boreholes to understand the layers beneath the sand. Every route was measured with centimeter accuracy, because one sandstorm could bury months of work overnight. Carving a river through sand. Hundreds of bulldozers flattened dunes. They cut down high ridges and filled low areas to create a stable surface. Compactors pressed the sand until it became solid enough to hold cranes and trucks. Then the digging began. One of the largest excavation operations in Israel's history. Every single day, 70,000 tons of sand were removed. The corridor stretched nearly 250 miles. More than 1,200 workers operated in shifts, enduring temperatures above 115 degrees Fahrenheit. The canal took shape with a wide U-profile, 150 feet across, 23 feet deep, and built with a slope so precise it varied by no more than 1 inch every 100 feet. Survey teams checked the elevation constantly. Everything had to be perfect. Sealing the canal. But the desert has a thirst of its own. If the canal was not sealed, the sand would drink the water within hours. Engineers leveled the base with a fine layer of sand. Then they poured concrete panels 4 to 5 inches thick, each one 16 feet long. Expansion joints were sealed with hot bitumen to prevent leaks. In unstable zones, an HDPE geomembrane was added beneath the concrete. It was anchored with steel and covered with sand for protection. More than 220 miles of canal were lined, one of the largest waterproofing efforts in the region. From above, it looked like a silver ribbon cutting across a sea of gold. A river needs more than a channel. A canal this large required an entire system of structures, bridges, spillways, siphons, culverts, aqueducts. Over 900 engineering components were built, each one essential to guide and control the water. A single failure could leave whole regions without supply. The first flow of water. After 15 years, the canal entered testing. Engineers opened the gates at the barrage. 500 cusecs, 2,000. $6,000. Teams inspected every mile, checking pressure and searching for leaks. When water finally reached the dry canal bed, celebrations erupted. Villagers called it the day the desert came back to life. It was more than water. It was hope. Desalination, turning salt water into life. But the water entering the canal was still seawater. And in the desert, Salt can be deadlier than drought. So the water passed through a chain of advanced technologies: mechanical filtration, sand settling. Oil separation, nanofiltration, and then reverse osmosis. Under immense pressure, seawater was pushed through membranes so fine they allowed only pure H2O to pass. The result was almost too pure, so minerals like calcium and magnesium were added back to restore balance and taste. UV light or ozone disinfected the final water. A trace of chlorine ensured long-term safety. Only then did the water begin its journey across the Negev. The desert begins to bloom. Everything changed when fresh water reached the desert. Land that once cracked under the sun began to heal. Farmers returned. Fields were planted for the first time in generations. Drip irrigation systems, an Israeli invention, delivered water drop by drop, saving every bit possible. The results were breathtaking. Tens of thousands of acres turned green. Orchards, vineyards, wheat fields, vegetable farms, date palms heavy with fruit. Seen from the sky, a long green ribbon winds across the desert, the lifeline connecting the north to the south. Villages grew, schools reopened, high-tech farms appeared where only sand once existed. A triumph of engineering and willpower. This is how Israel removed billions of tons of sand, carved an artificial river, and turned seawater into drinkable life. A story of innovation, resilience, and the human will to survive in a place where survival seemed impossible. Thank you for watching.